Alright, almost done with notes. Last section. Theorem 2.11 gives us kind of an extension of the power rule. What this is saying is if we have a constant in front of our function, constant in front of x to a power, when we take our derivative, we can basically keep that constant out in front and bring that exponent down and multiply with the constant and subtract 1 from the exponent. So the only difference from this and the power rule is that we have a constant sitting out in front and it just stays there. So for example, number 1, if we were to find the derivative of f of x, the 2 stays there. We bring the 3 out in front, so we do 2 times 3. That gives us 6 times x squared. Right, subtract 1 from here. So that constant just gets multiplied with that exponent. For number 2, similarly, we bring that negative 3/5 out in front. So we do 5 times negative 3/5, which is negative 3 times x, and we have to subtract the exponent. So negative 3/5 minus 1. So instead of subtracting 1, we can subtract 5/5. So we get negative 8/5 is our new exponent. And then for problems 4, 5, and 6, we're finding exact values. So to find the derivative of f at negative 2, first we find the derivative of f of x. Bring the negative 2 out in front, so negative 8 times x to the negative third, because we're subtracting that exponent. Now we can go ahead and plug in negative 2. So negative 8 times negative 2 to the negative third. Remember, all that means we get negative 8 over negative 2 to the positive third power. That's negative 8 divided by negative 8, which is 1. Alright, take a little bit here to try problems 3, 5, and 6 on your own, and then we'll check our answers. Give you a little bit of time to finish. Alright, let's go ahead and take a look. So for number 3, we get 15x to the negative 6th. 5, we end up getting 5/12. And the 1/3 out in front, multiplied by 5. Subtract 1 from the exponent, and then plug in 8. Number 6, we end up with 90. And the 3 out in front, multiplied by 5/6. Subtract by 1, plug in the 6.